Hello and welcome to the MathOS channel in English. In this video, I'd like to give a detailed proof of this nice formula. Here, h sub n denotes the nth harmonic number, classically defined by the sum from k equals 1 to n of 1 over k. We observe that h sub n over n cubed is equivalent as n goes to infinity to log n over n cubed, which is less than 1 over n squared, and this proves the convergence of the series, and we'll denote its sum by the letter uppercase S. In order to calculate S explicitly, the entry point will be an integral representation of h sub n. From this well-known identity, it's easy to deduce that h sub n is equal to the integral from 0 to 1 of 1 minus t to the n over 1 minus t dt, and using this formula, and after intervention of the symbols of summation and integration, we get s equals to the integral from 0 to 1 of 1 over 1 minus t times the series from n equals 1 to infinity of 1 minus t to the n over n cubed dt. Introducing the function f defined for t between 0 and 1 by the series from n equals 1 to infinity of t to the n over n cubed, we may rewrite s as follows. Then, an integration by parts leads to this new expression. On the one hand, since f of 1 equals zeta of 3, the expression in square brackets is 0. And on the other hand, it's better to rewrite the last integral in terms of g of t, which is defined by the series from n equals 1 to infinity of t to the n over n squared. So we have s equals the integral from 0 to 1 of negative log of 1 minus t over t times g of t dt, and right here a miracle happens, because this factor is exactly the derivative of g of t, so that finally s equals the integral from 0 to 1 of the product of g of t by its derivative, and this is equal to 1/2 times g of 1 squared. Now it's well known that g of 1 equals zeta of 2, and this is pi squared over 6. Hence, s equal 1/2 times pi squared over 6 squared, and this is equal to pi to the 4th power divided by 72. And the proof is now complete. A quick search on the internet reveals that there are plenty of such formulas. The great Euler discovered a very general one, and it goes as follows. For any integer q greater than or equal to 2, the sum from n equals 1 to infinity of hn over n to the q is equal to this expression. Taking q equals 2, this identity becomes the series from n equals 1 to infinity of hn over n squared equals 2 times zeta of 3. And taking q equals 3, it becomes now the series from n equals 1 to infinity of h sub n over n cubed equals 5/2 times zeta of 4 minus 1/2 times zeta of 2 squared. We already say that zeta of 2 equals pi squared over 6, and it's also known that zeta of 4 equals pi to the 4th power divided by 9t. Simplifying this last expression gives, as expected, pi to the 4th power over 72. But, as you can see, we didn't need such a general formula, and we could derive a quite elementary proof without any powerful argument. Okay, that's it for today. As usual, comments are welcome, and I hope to meet you again soon on this channel.